Thanks a lot, everyone, for joining us today. So I'm going to be joined by Venki Iyer here. My name is Ryan Lippert. And what we'll be talking about today is just the advantage of managed. And when we talk about that, we're really talking about Hadoop and migrating that from AWS to GCP. Now, before I turn things over to Venki, he's the real star of the show here, what I'm going to do is just quickly walk through Dataproc in general and what we see as our advantages, but really that's going to be hit home a lot better, I think, by Venki whenever he gets up and tells his own customer story about things. So let's talk about Dataproc and just, what is it, and then, why do we think that's important from a Google perspective? So I think that the best place to start there, if you're going to talk about Dataproc, is to talk about traditional Spark and Hadoop clusters and the way that we think about those and the way that those actually go into implementation and operation. So with a traditional cluster, what you end up having is within your cluster, you have your data technology, your governance, you have security in there, and then that lies on top of operations and management. Now, the issue with those traditional Spark and Hadoop clusters is that they're not really integrated with other tools. They've got to be shared between many, and it's really difficult to make those changes. And those changes end up creating something that we like to call the D-value chain of big data to some extent. And so this is probably familiar to anyone who's provisioned Hadoop clusters on premises one way or the other. But you've got to obtain servers first. From there, you have to configure servers. After that, you're installing the open source software. Then you're configuring that software. From there, you're optimizing it. Then you need to debug it. And then you can finally get to the point where you're ready to start to process data. And so that's a long cycle. And any time that you want to start that cycle over again to scale, you've got to go through each one of those individual steps. Likewise, if you get to the end of things and you say, hey, actually what we need to do is a reconfiguration here, you're looking at restarting that halfway through the process. And so what you end up with is a lot of lost time, and then that lost time is also sunk costs that end up going into getting to a point where really what you want to end up doing is processing data at the end of the day. And so if we can get closer to that processing data piece of things, that's going to be really what our customers are actually looking for. So the cycle that we just showed on that last slide, it usually leads to pain. So the first kind of pain is scaling pain. So anytime that you need to add new capacity in, you end up with a lag between when your needs come on and then when you can actually get that out and into production. And that's because there's just so much time that's required to be able to actually get the truck roll out and make that happen. There's also an issue from a utilization pain perspective. So the way that you usually see it is you've got your cluster, it's up and running, it's taking in data at the time that it needs to, it's processing data as it needs to, but then there are big inactive times as well. And so you're still paying for that inactive time, particularly if it's not a managed type solution. And then what that leads to is cost pain. And at cost pain, what you'd see is you're still reducing your costs as you move to Hadoop over legacy technologies. But what you're doing is because you've over-provisioned and because you've got inactive clusters, your cost is always going to be more than what it actually should be if you could actually get to a point where you're only using what you need. And so that's why we think that really the cluster and the platform should work together. And that's what we've tried to build here. And so when we think about that, the stuff that you'd rather not care about every time, that's the governance, the security, the operations and management. Those are all very important things when it comes to running a cluster, but it's not really what you care about. And that's the data technology that you're running in it. You really want to get to the point where you're looking at your analytics, you're looking at the solutions, and you're looking at the data processing, and being able to focus on that as opposed to everything else within your stack. And so that's why we've developed Cloud Dataproc, and that's where we think that our solution's pretty differentiated from what you'd see out there in the market more broadly. So Cloud Dataproc, it's fast, it's easy to use, it's low cost, it's fully managed, and it's all on Google Cloud Platform, which means that it's integrated with the other tools that we have within our platform as well. And so that really allows you to get up and moving a lot faster than you would be able to if you were trying to run this on your own, whether in a cloud and just doing your self-hosted or on premises. And so our vision, as I mentioned, fast. So let's make sure that it takes seconds to spin things up, not minutes, not weeks, definitely not months. As it can sometimes be. We want things to be easy as well. So be an expert with your data, but not necessarily the infrastructure. Let's focus on what we're doing from a data perspective, and then let's make it so that you only pay for what you're using as opposed to everything else in your, everything that you've got static that could be in your stack that's not actually working on things. And so when we actually look particularly at that last point from a cost perspective, we've had some analysts come out with some studies that say that when you look at Cloud Dataproc, particularly relative to on-premises, it's 57% less expensive than that. And then even when you look at EMR, it's going to be 32% less expensive. So the way that that ends up happening is as we move from on-premises to just doing it on Compute Engine or potentially in another cloud, then all the way across to Cloud Data Proc, what you see is that on-premises, you're self-managed for everything from code down to the creation and deployment. And then as you start to move from left to right on the screen, from a Compute Engine perspective, then Google starts to take over things like connectivity, deployment, and creation. But when you get towards Cloud Data Proc, you can see that the only thing that the customers and users end up being responsible for is really getting to a point where they're putting in their custom code, and then everything else along the way is taken care of for you. And so when we generally look at folks who are starting to do these migrations one way or the other, if it's a lift and shift from another cloud, if it's even a lift and shift within Google from self-hosted to running Dataproc, or particularly if it's on-prem to into the cloud, there's a set of common, 6 common kind of principles that we would typically look at and say, hey, here's what you should be thinking about. The first is separating compute and storage. As you move into Dataproc, the ability to do that is going to allow you to move a lot more efficiently. Use ephemeral and long-lived clusters. So kind of start to try to classify them in one way or the other. If you have a cluster that always needs to stay on, make sure that you've got the data that needs to be processed in that cluster, and then the ones that you can spin up and spin down quickly, separate those out. You also want to right-size the clusters per use case as well. So understand what your use case is and spin up clusters that make sense for that. This create and delete clusters often goes very well with the ephemeral and long-lived clusters. There's no need to keep those up and running if you can spin them down, and then with a 60 to 90 second spin-up time for those clusters, you can bring them back anytime that you need to. Replacing HDFS with cloud storage, and then finally using Dataproc jobs through the APIs that we offer. So that's a good Google overview. But I think what everyone's really here for is to hear more from a customer, to hear about how this actually goes, potentially warts and all, whenever it looks like a lift and shift here. So with that, I'd like to introduce Venki. Venki is a software engineer from Thumbtack. So everyone give a good hand to Venki here. Green button forward.
Thanks, Ryan. Hello, everyone. I'm Venki. I'm a software engineer at Thumbtack. In the fall of 2016, we decided to move our self-hosted Hadoop setup, data infrastructure setup from AWS to managed services on Google Cloud. And today I'm here to tell you that story. But before I begin, let me offer you a quick intro on what is Thumbtack. In the world around us, it would seem that capitalism exists to make people lazier, and we do our bit by trying to solve this problem. Why is it so hard to hire a plumber, or a gardener, or a photographer? You can buy anything you want with one click. You can book travel around the world in a matter of minutes. But when you want to hire a piano tutor for your kid, you're forced to use the analog world. Maybe talk to somebody. Look up Yelp or Yellow Pages and try and make a few calls and see what works out. Thumbtack is an online marketplace that connects customers to professionals who match their specific job requirements, their schedule, and their budget. And Thumbtack is also the platform that enables professionals and small business owners to focus on what they do best, to focus on their core trade. And Thumbtack works on their behalf to acquire customers with high intent for them. And like any other internet company, internet business in today's age, we are highly reliant on data. We need data for core product features like matching that I just talked about, for paid customer acquisition through SEM channels. We need timely and reliable data to infer our top-line metrics, like customer growth and revenue. We need data for analyzing our experiments. We need data to train our machine learning models. I'm sure a lot of you will find this all too familiar. So let's begin the story of how we at Thumbtack attempted to solve for these requirements. And we begin, and we begin with a state we were in a little more than 3 years ago, the V0 infrastructure, or rather the lack of it. So we had this PHP website, and we used to run a daemon that would collect events from those website servers, which we would dump it into MongoDB for whatever reason. We had a bunch of Python scripts that would read those events, do some data aggregation, and do an in-place update, again, for whatever reason. And querying this infrastructure was very slow. We could analyze only one experiment at a time. And if by chance you wanted to find insights into relational data, you kind of go into a completely different world of a Looker instance, which was hooked on to a live PG replica. So very fragile, very slow, not very feature-rich, and yet somehow comprised of complex and convoluted code. So this was clearly a problem statement that we had to kind of attempt to solve. And that began with our first generation of infrastructure. So we set up Cloudera Hadoop on a bunch of AWS EC2 instances. We set up Spark on it. We converted all our data processing from like random Python scripts or whatever to Scala, essentially Spark jobs. We wrote all the data output in Parquet format. We configured Cloudera Impala as a SQL engine on top of that Parquet data. And we used a visualization tool called Mode and hooked it on to the Cloudera Impala so that our analysts can now create fancy dashboards. This infrastructure was the first generation that powered our experiment visualization tool that we called Prospect. It also powered our first ML prediction API serving, which we called Matchbox. And we set up Airflow. We used Airflow to orchestrate all these jobs, to define the schedules, to define the dependencies between jobs on which should run after what. Overall, a huge step up from where we were before, but not without its problems. The first of which was we were continuously playing musical chairs with the capacity, right? This is where the kind of the D value chain that Ryan talked about kind of commences for us. Jobs would step on each other. Invariably, what would happen is a lot of scheduled mode reports would be scheduled to run at 7 a.m. or 8 a.m. so that people get fresh data when they come to the office, and they would overload the cluster. Very frequently, we would field queries like, hey, my dashboard looks off. Is it a data problem, or did we really tank our revenue yesterday? So we clearly needed to do something about the reliability of data there. And ironically, in spite of all that, during midday, if nobody's running any ad hoc queries, the entire cluster was idle. So there was very little elasticity in our infrastructure that we had set up. Data was replicated within the HDFS. It maintains multiple copies, but that was it. So we had this slight durability risk as well. And what it meant as a team for us is this was a huge time sink in terms of operational workload. For engineers from Google and Facebook and the like to appreciate this a bit more, I would like to tell that this was a team of 6 engineers responsible for everything from setting up the clusters to setting up Hadoop and Spark on top of it, to actually writing the data infrastructure that we really needed. So this was a huge time sink. So we had to we were at a point where we had to start thinking forward on how do we solve these problems. And these were our alternatives. The most obvious one was to kind of double down on the same path, which would have inevitably translated into separating out our compute and analysis clusters, which would have meant investing in some cluster management tool that would help us with capacity planning, maybe it automates some operational tasks. But to summarize, what this would have meant is we would have had to hire our way out of that thing. And for companies like ours, that thing is a lot easier said than done. So that was when we started thinking about managed solutions. And these are the 2 options that we got to compare head on head. So Dataproc and BigQuery offerings on Google, and EMR and Redshift offering on AWS. So comparing Dataproc and EMR at the time took about 30 minutes to spin up a cluster. It has improved now a little bit, but again, we thought that really doesn't get us out of this capacity planning thing, right? We would still have to spin up clusters and figure out how many jobs or which jobs can we run on this one. Whereas Google Dataproc can help us think in terms of job scope clusters. So I'll get into the details of that in a little bit. And comparing BigQuery and Redshift, we definitely like BigQuery more. Because A, it was truly serverless. It supported nested data types, which we used a lot of. And it was an added advantage that it kind of worked on Google Sheets as a federated data source, which would please a lot of people in the company. So it was definitely advantage Google at this point. And this is kind of the story that led us to the decision point of where we decided to take the plunge. So in the next section, I want to talk about how do we get on from there, right? Decisions like this are seldom unanimous. There are counterpoints within and outside the team. And even for us who were in favor, we had to acknowledge our failability here. We had to acknowledge, is this the right path? Or if it is, how do I prove it, right? So we started thinking about how do we get some initial success pointers? How do we say that we are on the right track? So for that, what we did is we partnered with our analytics team to identify some of the important data sets and just copied them over to BigQuery. And then the mode visualization tool that I talked about, we pointed that to BigQuery instead. So there was some work involved in changing the SQL from the Impala SQL dialect to BigQuery standard SQL dialect. There were some minor changes. You had to handle the timestamp fields differently, and so on and so forth. So it took some kind of documentation and some education part of it, but overall not such a daunting task, right? And in order to keep that data fresh, what we did was we leveraged our Airflow infrastructure and inserted a small cross-copy job at the end of our data pipeline. So we had this bunch of processing that would end up producing a Parquet output. And then we had one downstream job that would read this Parquet file, convert that into Avro, dump that into GCS, and update that to BigQuery. Right? So that data in BigQuery remains fresh, while still all the processing is on AWS. So this gave us two benefits. Like in hindsight, I think this turned out to be a really good call. A, because analysts who were the #1 customers of this data infrastructure gave a thumbs up. They found, their queries, they found a quick turnaround time from BigQuery. The failure and timeout rate was markedly a lot lower than before. So it was an immediate win for them. So that was good. And this gave us a good migration path, right? So now we could think about migration without interrupting any of the business workflows, interrupting any of the other team's plans. Your dashboards will still work. The data is all still there. While in the background, one data pipeline at a time, we can take and move it from AWS to Google. So with that headwind, we really doubled down and started kind of building some of the other pieces on top of Google Cloud that really enabled us to leverage this infrastructure effectively. And now I'll kind of talk a little bit more about job scope clusters, right? This is an entire paradigm shift. Now, instead of thinking of setting up a cluster with this many CPUs and this much memory, and figuring out how many jobs can run on this cluster, now we could think about, hey, I have this job. What resources does this job need? Since the cluster can be spun up in like 60 seconds or 90 seconds, that job can go ahead and spin up the cluster it needs, and then just run without any interference from any other job. It just kind of felt like good parenting, right? Job 1, you run in cluster 1. Job 2, you run in cluster 2. No fighting. And it worked. And some of the other things that we discovered while we were setting up our infra on Google was we realized that for downstream jobs, it was much more performant and cost-effective to read it from GCS rather than BigQuery. So when you dump data into BigQuery, you stage that in GCS anyway, because that's how the BQ load works. We just made sure that we gave that path a formal convention so that we can address our data on GCS as well. And downstream Spark jobs could just read data from GCS. We leveraged the audit logs from both BigQuery and Dataproc, fed it back into BigQuery so that we can query it and create dashboards on it. And we use that to gain insights into our usage and cost of how we are using this platform. And finally, we use the fine-grained data access and auth management in BigQuery to kind of really share data sets to wide range of teams, including the contractors as well. But the migration was not without its challenges, right? So the first two I called out here are required non-trivial amount of code refactoring. Now we are dealing with clusters that we spin up and down. So HDFS is an ephemeral storage now. So we really had to move all our data storage into an object like Google Cloud Storage. At the time, BigQuery did not support Parquet, so we had to convert everything into Avro, and we got into some gnarly data type conversion issues. But yeah, that needed to be solved. A couple of runtime challenges. One was a difference in performance characteristics. So Dataproc tries to fit 2 Spark executors per worker, and we realized that, and it tries to allocate like roughly 50% of resources to each of those executors. And we realized that if we tune a memory a little bit, like heap memory or out of heap memory, Dataproc would sometimes only schedule 1 executor on 1 worker. And we would be at a loss, or we are throwing like this, we have spun up this 24-node cluster, but still it takes twice as long. I mean, why? And then we realized it's only using half the cluster. So that took some kind of Sherlock work, investigation type thing. And the other thing was cross-cloud networking. Now we are moving data back and forth. So we had to set up some networking gear. We had to set up the auth keys that can be kind of shared and rotated in a good way. And all this had from a technical perspective. And from a management and organizational perspective, what it meant is the time spent on migration is the time not spent on the feature requests that all other teams have. So this is something that we just asked the company to take us up on good faith, and we're grateful for them for their patience. But we did overcome it. And we did end up having, in today's state, we are leveraging Google to a good effect. We have compounded the number of jobs and queries we are running. We create and destroy more than 700 clusters per day. We run more than 12,000 queries a day. We added streaming ETL capabilities. We used deployment manager to have this entire configuration on GCP as code. So all in all, I think we did kind of overcome all that to come to a very good state here. And we also used the Google's organization and projects kind of hierarchy to kind of create multiple projects and to control data visibility, and also to kind of have per department billing, so to speak, so we could figure out where our expenses are coming from. Yeah, talk about this. Right. So that's kind of the story of how we came to a decision point, why we decided GCP, and how we migrated to GCP. And in this last section of this talk, I want to kind of just share the thoughts as we reflect upon, so what do we kind of make of all that things? How did this project go for us, right? Starting with this question that, did we truly achieve what we set out to achieve? And several things come to mind. I mean, we currently run a lot more, like I said, a lot more queries, a lot more job, a lot more capabilities on the data infrastructure, as well as we are now, as a team, taking on more problems, even outside of the data scope. So if I have to condense all that into one word, that's time. We gain time. For a limited set of engineers, we really kind of figured out that we could save time and spend somewhere else wisely. And one other thing that I think about that we could not have gained without this migration is to truly democratize data. The scale of BigQuery, the scale and the flexibility with the creating both normal and materialized views and have different auth scopes for each one of them has really helped us to share data sets with almost all the organizations, all the departments within the company, and everybody across the company is leveraging that data. So that's a huge win for us. So those are the good aspects of it. So there is also kind of one more way to think about all these things is, there are plenty of risks along the way. So how do we think we did with the risks? Starting with planning fallacy. So this is, planning fallacy is when, when you're making a plan, you're like super optimistic. I'll do this in like 3 months, but you overshoot it, right? And we did fail for this. We kind of thought that we should be able to do this within 6 months from MVP to all the way to the end, but we did bleed into the third quarter of the migration, but we did kind of put our heads down and complete it. The other kind of estimate that we overshot by a lot is we thought we would spend less on Google, but that did not turn out to be true. But that's OK, because now we are actually spending more because we are using that data a lot more. We are running a lot more jobs. We are running a lot more queries, and that's where that cost comes from. The second kind of risk I think about is the sunk cost fallacy. Sometimes this migration kind of keep going on for like months and months, and somewhere along the halfway through, you think about, hey, I've come this far, and that becomes the only reason for just kind of keep going forward. It happens when you don't have an option to go back, or going back becomes like really expensive, right? And this is an item where I think we did really well. Because we always had a path of going back. We didn't kind of dismantle our AWS infrastructure until we were completely here. So if we had hit a roadblock, if we at any point of time thought that, hey, this is not working out, we had other alternatives. And one other thing that helped us is we had scoped in the beginning that we are only going to move our data infrastructure and nothing more, right? And that scope remained unaltered throughout this project. And that was, again, one other good thing in hindsight. So these two are more with respect to the migration-related risks. The third risk I want to talk about is more of an existential risk when you operate in a multi-cloud environment. So Conway's law, I don't know if you have heard about it. It states that organizations will produce designs that will have the communication structures that they have within the organization. What it translates to in reality is if your one team is responsible for your Google infrastructure, if the other team is if some second team is responsible for your AWS infrastructure, when you think about solutions, can you truly think about one single base, data center infra? Or otherwise, I mean, if the teams work well, you can do that. If the teams don't work well together, you would have one solution here and one solution here that would not talk to each other, right? So this is, like I said, this is an existential risk. We're completely not out of the woods yet. But the good thing is just being aware of it is a very good step. And this is something that we have to be mindful of from here on. This never ends. So that was like a brief scorecard on how we did. So now I would kind of take a liberty to kind of give a scorecard on how Google did. Overall, I think the uptime has been pretty solid. The scale and load that we throw at Google is like handled, no big deal. Their response. Their support teams have been pretty responsive for both like low priority issues as well as high priority issues. These were the good parts. But that does not mean that there were no issues at all. They're also a software company. They also roll out software. Things go wrong. Some of the things I wanted to highlight was like last year, we had a couple of BigQuery related incidents. Essentially, they were breaking changes. They were not backward compatible changes at the Google's end that kind of got our data processing to a grinding halt. One of this was, for example, the nullability of Avro fields and nullability of BigQuery fields. The requirements were made strict that they should match, which wasn't the case before. And we were freely using strict fields and mapping them to nullable fields in BigQuery, so that broke everything. The other thing was, again, some sharding changes that we had to kind of set a particular variable. And more recently, we had a bunch of issues with dataproc. There was one where the GCE images weren't available. There were a couple in June. Again, one related to some networking, and one was something else in the back end. And both of these were unfortunately kind of impacted the entire region. So maybe that's one CVB, or that's a term that we use in Thumbtack called could be better. So one could be better that I would call out is probably have a rollout plan that, even if it goes bad, does not impact the entire region, maybe just a few AZs within a region. But it did force us to kind of rethink, and we were able to leverage our Airflow infrastructure to move from a single region to be multi-region. And since the BigQuery and the GCS layer were multi-region anyway, it was easy for us to do so. And another kind of could be better that I would call out is, so for example, that April issue had an amazing postmortem, but the June issue didn't. So it's all a great learning experience to learn about what went wrong. We can understand more about how everything works internally, and sometimes it kind of can get to action items for us, that if we could do this, we could kind of protect ourselves a little bit more. But overall, I think it's a great time to be out there and building products on these cloud platforms, that you don't have to think about so many kind of complex and sophisticated infrastructure things. Google, given its scale with search, has solved these problems. Their infrastructure works for mind-boggling scale and complexity. And it's great that they are making it available for other peoples to use it through their cloud infrastructure. I mean, which other company in this world can think of building a spanner, for example, right? But as users of it, it still takes work. It still takes a lot of thought on how do you want to go about it. It still takes dedication. It still takes coming up with a cohesive plan and making trade-offs. So with that, I'll conclude my talk. Thank you very much for listening. And if you have any questions, I can take that.
So Venki, thanks a lot. That was a terrific presentation. I think that everyone here has enjoyed it. Because I've got the special mic, I'll kick off with a few questions just to start. One of the first things I thought the crowd might be interested in hearing about is, you talked a lot about multi-cloud there. Can you talk a little bit about the egress cost there and what that's been like for Thumbtack?
Right. So we're kind of exporting a lot of data out of AWS, so we're mainly talking about egress costs in AWS. It's not been that high in the sense that, like, for example, our Scoop jobs still run, every single time they run, they kind of take the entire database snapshot. There are some kind of nice-to-have optimizations. We could have streaming replication into Google, which would reduce the egress costs. But overall, those figures are like not that high that we have to drop everything and fix that thing right now. Like I said, again, this goes in terms of how we think about our time. We kind of prioritize products and projects that are important to our company's top line first. But all in all, I think the egress costs are pretty much under control and manageable.
That's great, Venki. And so I think another thing, you've talked a lot about where you've been and where you've come to. What's next for you at Thumbtack? What are you thinking about in terms of the new use cases you're going after, or what's next for your infrastructure there as you think about data and analytics in particular?
Right. So having a robust infrastructure like this for base data processing really becomes a foundation on which we can build some more sophisticated and complex processing. We are now trying to invest a lot into our machine learning infrastructure. We are using TensorFlow. Currently, we are using TensorFlow serving on AWS, but we would like to kind of evaluate CloudML, as well as we are kind of evaluating Dataflow to kind of create the feature extraction pipelines that we could run in both streaming and batch modes. So those are some of the things that kind of are coming up and in the pipeline.
That sounds great. And if I might, just one more question for you before let's open it up to the audience. When you think about what we can do from a Google perspective, or what other services that we could potentially offer, is there anything in our stack that you'd like to see that maybe you're not currently seeing that we could be working on?
Yeah, so I think one of the things that I missed on Google infrastructure while setting up everything was having a pub/sub system that supported some level of partial ordering. I'm a huge fan of the Kafka paradigm of messaging. Kafka or Apache Pulsar both have some partial ordering, so that enables, for example, you to have like database streams into your pub/sub system. Google pub/sub kind of has taken a different philosophy. For scalability, they have traded off the ordering part. That's because the Google Dataflow stream processing pipeline is very feature-rich. It can do some event time windowing and reorder there. But if you're not really using that, we would really want to see if some heavy lifting done on the pub/sub side. I think that would be very useful for us. And I've recently learned that I think Confluent and Google are partnering to set up managed Kafka on GCP. So that's something we would check it out and see what we can build on top of that.